as well. So, of course, in some sense, this is cool, but there are several challenges about this. One is that it's very hard to run a project for 1,000 years. It's very hard to have everybody agree that we're going to transform Mars into a mini Earth, and it's going to take 1,000 years to do that. And until we get to that point, you just have to pay for it. Okay. So, I mean, it's going to cost money, for example, to do that. And, you know, who invests today money for things that don't pan out for another 1,000 years? Okay, so it's very hard to do. So that's one issue. The other issue really is 1,000 years from now, we might be able to travel to other stars. We might be able to travel to other Earths, ready-made, planets that are a lot more like us than Mars. So it could be that Mars is just going to be like, you know, like an island in the middle of the ocean where, you know, after hundreds of years of exploration, we're still not building a city on it because we were able to go to continents that are beyond. So the thought here is that maybe in 1,000 years we'll have space travel means to go to planets around other stars, and nobody's just going to care about turning Mars into another Earth. So that's another idea. Okay. There's a third idea, which is maybe we should transform Mars. Maybe we should transform people. I mean, we can do genetic engineering and maybe change your genetic makeup to make you able to breathe carbon dioxide, to not freeze when the temperatures are very cold. Maybe we can transform the human being into something that could live on Mars. That's wild, but that's also possible, especially if you give it 1,000 years of science. So I don't know if this is going to be the future of Mars. I put these 2 pages for you guys to just think about the possibilities of the future.
That's cool. Hey, kiddos, I gave you a card if you want to, when I have more here. Pascal and I said maybe up to 15 more minutes. I don't know how Pascal's doing, but we want to respect his time, and he has other things, of course, to do in his day.
Okay, we have a good 10 minutes here.
10 more minutes. So what I'm going to do is I'm going to take Julia's question, but then anybody else write your question on a card and put your name on it, and then I'll pick my favorite ones, which is horrible, but we only have time for so many, right? Right? So put your name on a card and give it to me when you have it. So Julia, start us off. The rest of us, give me a card if you want to be called on, please.
So you said that the spacesuits weigh 300 pounds on Earth. So
yeah.
When the astronauts are going like into a spaceship, would they have to like wear that? Would they have to like carry that 300 pounds? Or
yeah. So right now the spacesuit they wear is not that spacesuit. The 300-pound spacesuit is the one they need to go outside in space. So when they are in the rocket, they're not wearing that spacesuit. They're wearing a different spacesuit that's much lighter. But it doesn't protect them so well either. So the spacesuit that weighs 300 pounds right now, we take it to space and we only wear it in space. And when we wear it like around the Earth in zero gravity, it doesn't weigh anything. You know, again, it has the bulk, like it's hard to move, if you will, because it has the bulk of a 300-pound suit, but it doesn't weigh that much on your back or your shoulders. It's weightless.
Right. Yeah, out in space. Yeah, when you're in microgravity, it has zero weight to us, zero apparent weight. So Connor, Connor wants to talk a little bit about food on Mars, assuming we can't bring everything forever. So Connor, ask your question and see what you can say.
So we only have food and water for enough for 1 month, and we also want to start building stuff. But should we do both at the same time, build and look for food and water?
Well, now look for food. So we also brought plants, so talk about that as well, please.
So like grow plants? Should we like work on growing plants and build at the same time, or do one or the other at a time?
If I were you, I would make sure you can survive first. I mean, you need food to build. So I would say focus on getting your plants going first. And then once you're sure that you have a new crop coming and you can survive on Mars, then you start building buildings.
And is there anything, they asked about things like animals, you know, is there any way to bring animals with us and have them reproduce and do things, or is that just not likely for the first couple of waves?
You know, I would love to take my dog, for example,
Yeah.
to Mars, and I think animals should be able to travel to space with us. You know, in the end, it's not just humans going to Mars; it's life on Earth that's going to Mars. I agree, of course, that in the early missions, it's going to be hard to take animals with us. Although I wouldn't even be surprised if on the very first mission we took a little squirrel or
Yeah.
chipmunk,
See
like
that,
a little pet, just to keep the crew happy and to symbolize the fact that it's not just humans going, but all life on Earth. But down the road, I wouldn't. I can imagine something like Noah's Ark, you know, where we would send all kinds of forms of life from Earth to Mars,
You know what I mean?
and get an Earth zoo on Mars.
Cool. Good idea. Charlie Stapleton's talking about oxygen and how we could possibly make it. So, Charlie, do you want to ask that question?
Yeah, like, would we be able to, like, build, like, oxygen generators? Like, I've read a few, websites that said that you can, turn, stuff into oxygen. I've read, someone told me that you can turn something into oxygen.
Yeah. Yeah. So, you know, I was going to say oxygen is really super important because we need it to breathe. So if you can't breathe, forget about eating or building anything. Okay, so oxygen is like really a very fundamental need. So the good news here is that the Martian atmosphere is made of CO2, carbon dioxide, and CO2 has O2 in it. So all you need is some energy to chemically transform the CO2 into oxygen and then, you know, carbon separately. So we have the means to do that. We can, all it takes is energy. So we just need a very good power plant, like a nuclear power plant on Mars. So you guys should bring that with you or have one waiting for you there. And then over time, you can transform CO2 in the Martian atmosphere into breathable oxygen. And the good news about oxygen, too, is that it's very good rocket fuel. So you can be building up air that you can breathe, but also, I mean, you can build up reserves of air that you can breathe, but also fuel for you to fly back to Earth or go anywhere else.
And also, it was another thought. Do you think we could possibly be able to make those things from Star Wars, like for any planet, you can just take them and it just sends out oxygen no matter what?
I couldn't hear
So
that.
some kind of device, can we make some kind of device similar to Star Wars where it would just start producing oxygen and fill up a whole planet's atmosphere with oxygen? I think the answer is the 500 years to get it to a certain point for plants to grow or whatever, that answer. is what I
Yeah,
think.
you know, it's hard to transform a whole planet. I mean, you know what? We on the Earth, we are worried about a few degrees of increase in temperature in our atmosphere, and we're not even sure how it's happening exactly. So it's very hard to engineer a whole planet and, you know, make it livable if it doesn't have life in the first place. But I see all this as being possible in the future. You know, if not you guys, your kids or grandchildren will start seeing some of that stuff.
And then Anthony was wondering if there are any other problems that you can think of that we might face on Mars other than the ones that you listed in your book.
Well, you know, one of the problems that I like kids to think about because it's fun but also important. It's not just on Mars; it's also on your way to Mars and back. Okay, on your way to Mars and back, one of the greatest threats to you guys, okay, is radiation from space. So the best way to protect yourselves from radiation from space is to have a little radiation shelter inside your spaceship going to Mars, coming back. Okay? So this radiation shelter is going to be very heavy. It's made of lead, and you can only spend so much time in it because it's very small. But when there's like that eruption from the sun or like a big shower of radiation from space, you'll be happy to have that little shelter you can go hide in, all right? Now, the rest of the time, you're still not protected. You're going to have radiation from space and from the sun hitting you. But a good solution for that is to use hydrogen to protect yourself. So where do you find hydrogen in the stuff around you? Well, it's mostly in water and also in food, okay? Water has hydrogen, it's H2O. Food has hydrogen because it's carbohydrates, right? All right. So what you want to do in your Mars ship, going to Mars and coming back, is to store all your food and all your water in water tanks and food bags, basically in the walls of your spaceship, so that it's protecting you. The hydrogen in the food and the water is protecting you from space radiation from the outside, okay?
Wow.
But the funny part is,
Okay.
as you go through your trip to Mars and come back, okay, the water gets recycled. So you go to the bathroom, you pee, and you recycle the water and you keep drinking it, so that's fine. But the food, we cannot recycle the food right now, okay? When you go to the bathroom and you poop, there's no way to turn the poop into food again. But you can't just throw out your poop into space. You have to save it because it still has all that hydrogen you want to protect you from radiation. So as your mission to Mars unfolds, okay, you have to store all your poop in little bags and put it back in the walls of your spaceship to protect you from radiation.
Wow.
Okay, so you're going to go to Mars. When you first leave the Earth, you're in a spaceship and you're surrounded by water and food. But by the time you come back from Mars, okay, and you've consumed all the food, you are going to be in a spaceship that still has water, but it's mostly recycled pee, and all the food by then has been turned into poop. So
And then
you're going to have to deal with that.
would we be able to use that on Mars, or is there too much bacteria in that to use for? Like I'm wondering about the soil on Mars doesn't have nitrogen and phosphorus and the things
Yeah.
that plants need, but how do we do that? Can we use that?
You could actually work on the chemistry of the soil on Mars. That's a very good point, Mr. Solar. So you should work on your poop can enrich the soil on Mars and make it more friendly for plants to grow, and so can your pee. So all of these things that we consider as waste on Earth turn out to be a resource in space, okay? Because things are so scarce once you get out to Mars or in space.
Well, Pascal, I think that's about the time that we need to let you go.
Okay.
We so appreciate all of your time and effort. I'm looking at their note spirals and seeing pages upon pages of written notes, so I think they're getting a lot that's going to help us with the rest of our simulation. We love your book. We love the time that you spent with us, and we want to really thank you for everything that you've done.
Thank you, guys. I really enjoyed this. You are very impressive. You're very smart. And once again, I'm so glad that you have Mr. Solis as your teacher, because he's taking you in the right direction here. How many of you would now be interested in going to Mars? Now that you... Okay.
We don't have the technology.
I'm counting a few more hands. Okay, that's good.
That is good. You convinced some. Must be the poop in the walls that got them.
Yeah.
All right, Drew wants to say one thing as a parting word, and then we're out of here.
On the back of the book, it says that you to paint like space art.
Yeah.
That picture is really good.
Oh, thank you.
He really likes your artwork.
Okay.
So.
I have a website where I have more paintings if you're interested.